Hello, let's learn about rectilinear motion. This is motion on a line on the coordinate plane. All right, so here we have our doggy graph. If it is moving to the right, it is moving in a positive direction from the origin. If it is moving to the left, it is moving in a negative direction from the origin. All right, so our dog can move in a positive direction or in a negative direction. We can directly observe the motion, marking the position at different times, or we can make a graph of time versus position with respect to the origin. So we have two graphs here. We have one that looks just at position, and we have one that looks at position and time graph. So we have a movement graph, which is the number line, and then we'll look at the coordinate plane where we have movement and time graph. All right, so here our dog is going to move 5 units to the right. And then our dog is going to turn around and move. Just have to go right through them. 10 units to the left. Right? So it's gone 5 units of the left of where it started. Right? That's the movement of the dog. If we look at the coordinate plane, we can not only see the movement of the dog, what direction he was going, we can also see the time. Right? So the horizontal axis is time, that's the x-axis is time. The vertical axis, the y-axis, is the position on a graph. So the position function is often called s of t, where s is the position and t is the time. S of t is the position changes as time changes. So position is a function of time. Here we can see that same movement graphed on the coordinate plane, where we can see not only the movement and the direction, but also time. All right, so here's our dog moving 5 units to the right, and it took the dog 4 seconds to do that. And then here's our dog moving 10 units to the left. So it took him 4 seconds to move to the right, 8 seconds to move to the left. Notice that this is a line. We have a linear graph here, right? And we know a line has a constant rate of change. So the first 4 seconds, the rate is like at a constant rate, right? So it looks like, so overall he's going 5. So it would be 5/4. I don't know what units this is. Let's just call this feet. 5/4 feet, right? Per, I don't know what time of unit is, per minute. 5/4 feet per minute. We're not given units on this graph. And then it moves a constant rate to the left, right? And so here the dog is moving, so it took him 8 seconds to move 10 feet. So same rate, only in the opposite direction, right? So still has it's going 5/4 feet per minute, but now he's going to the left instead of the right, right? So on a coordinate plane, we can look at movement over time. What does moving to the right, moving to the left, and being stopped look like on a graph? Right, again, x-axis is time, y-axis is distance. Right, so if something is moving to the right, it has a positive slope. If something is moving to the left, it has a negative slope. If something is stopped, it has 0 slope. There's no change in the position, right, because it's stopped. Time is still going on, right? That's why we have a line, but the position hasn't changed if something is stopped. Interpreting a position graph. So here we have a position graph, right? So, and I'll just kind of mark points as I read through them. At t equals 0, the car is 10 kilometers to the right of the origin. Maybe the origin is home, right? The value of x decreases for 30 minutes, indicating the car is moving to the left, right? So until the car gets there, right, the car is moving to the left. How do we know it's moving to the left? The slope is negative. right? How do we know it's 30 minutes? We can see that along the time, and this time we're given units. All right, so the x-axis is in minutes, the y-axis is kilometers, so we can see for 30 minutes our car moved to the left, all right, and overall it moved 30 feet. So 30 feet to the left for that first 30 minutes. Then the car stops for 10 minutes at a position 20 kilometers to the left of the origin. Right here we have a slope of 0 until we get to here. Right? 0 slope means the car's position did not change. It stays at that same position. Time keeps going on, right? It's now 40 minutes later, but that position hasn't changed. Right? So now the car is moving again, this time in a positive direction. Now the car is going, if the origin is home, I guess the car is going back home now. All right, so the car starts moving in a positive direction to the right at t equals 40, and all along here until the car stops. When it reaches the origin, the car is moving in a positive direction. So the car reaches the origin at t equals 80 minutes. So for 40 minutes, the car is moving in a positive direction. All right? So maybe the car was 10 kilometers from home, maybe visiting someone, and then had to pass his house. Maybe he had a doctor's appointment, right? And so he's at the doctor's appointment. I guess it's a short doctor appointment because he's only there for 10 minutes. And then he's going back, right? And it takes him 40 minutes. Notice that the slope is much steeper, right, on the trip to the doctor's office, if this is the doctor's office, than it is back home again, right? This has a much steeper slope right here. Maybe here he's on a highway, right? And over here he's on a back road, right? That has a less steep slope. All right, so let's use the position and time graph to describe how the puppy is moving. All right, so notice this was all linear function, so the car here is moving at a constant rate, right? At different rates, right? From when he's going to that initial position, or going from this initial position to this new position, right? So this is his initial position. Let's call that position 1, I guess. He stops here. And then here's the origin again. Let's call it home. Seems like the car would go home. All right, so not the same slope from the initial position to position 1, from position 1 to home, but from initial position to position 1, same slope, moving at a constant rate. From position 1 to home, same rate, moving at a constant rate. Here the dog is not moving at a constant rate. Notice we have a curved function, meaning he's speeding up and slowing down. All right, but we can still interpret his position. It doesn't matter whether it's linear or not. All right, so here the dog is moving in a positive direction, right, until about 5 seconds, right? So right here, the dog is stopped. Maybe this is a puppy. They don't stop for long. So this is positive. Oops. Oh, I like to do green and positive. Positive and green. So this dog is moving in a positive direction. Right? So if we look at our graph here, so the dog starts off right where the dog is located, -3, so he's 3 units to the left, and he moves in a positive direction, and I don't know, it looks like a tad more than 6, whatever a tad is. Right, so he moves in the positive direction, and then the dog turns around, right? So it stops and turns around. Right, and then its dog starts to move in a negative direction. And it still looks like maybe it's moving in a negative direction, but it's not moving very far. Right? And maybe it's even stopped. We could even say maybe that's a horizontal line. It's a little hard to tell. Maybe that's where the dog stops, right? And so here the dog is just stopped. We'll assume that's a horizontal line. It's a little hard to tell. If it's not horizontal, it's not very steep, right? And so this is a negative direction. And of course, negative direction here is going to mean left. And positive direction here is going to mean right. Sometimes positive will mean up if we throw something up. Sometimes negative will mean down when the thing comes down again. So the dog, after it stops, it moves in the negative direction. And it goes until it's at -1. It's about there. Oops, can't connect again. And then the dog is just stopped. So time will keep on going, but the dog has stopped. Maybe the dog is tired. Thought I had one more. Yeah. Actually, this is going to be on the next video. So I'm going to end this video, and then we're going to look at position and velocity. All right, so thanks for watching, and bye for now.